In this video, we're learning about the 4 points of concurrency. So before we learn about points of concurrency, we need to understand what concurrent lines are. And the definition of concurrent lines are 2 or more lines that intersect at a single point. So the first point of concurrency that we'll learn about will be called the incenter. And it just so happens that in a triangle, the 3 angle bisectors will meet at a point. And that point is called the incenter. So let's look at a geometry sketchpad investigation to see how that's possible. So in this geometry sketchpad diagram, I have a triangle. Then all these red lines are the angle bisectors. And no matter how I adjust the triangle, the angle bisectors will always intersect each other at one point. And that point is called the incenter. Now, there are a couple interesting things about the incenter. And before we learn about them, let's look at this problem. So, in this problem, the question is asking, is AD an angle bisector of angle BAC? And the answer would be no, because as we learned in the previous video, angle bisectors are always equidistant from the sides of the angle that it's bisecting. So as you can see, D is 10 feet away from point D and 9 feet away from point C, so it's not equidistant from the sides, therefore it's not on the angle bisector. So, similarly, the incenter will be equidistant from the sides of a triangle, and it makes sense because if each angle bisector is equidistant from 2 sides of the triangle, then where all 3 of those angle bisectors meet, that point, which would be represented by A right here, will be equidistant from the 3 sides of the triangle. Now the reason why AR, AS, and AT are all perpendicular is because when you measure distance, you always hold the ruler perpendicular to what you're measuring. Just like if you were measuring your height, you would hold the ruler perpendicular to the ground. So in the figure on the right, A is the incenter. So using that information, we could solve for x. So we know that TA is equal to 8y plus 22, AR is equal to 10y minus 10, and AS is equal to 15x. So first let's find y by setting TA and AR equal to each other, because we know that they are equal because they represent distances from the incenter to the side of a triangle. So when we solve, I'm going to start off by subtracting 8y on both sides, and we get 2y, and then add 10 on both sides, and we get 32 on the other side, divide by 2, and we get that y is 16. So TA will come out to 140, and AR will also come out to they'll both come out to 150. So now, since we know that TA and AR are 150, we could set AS, or 15x, equal to 150. And solve for x by dividing both sides by 15. And we get that x is 10. In this next slide, we will learn about the point of concurrency of the perpendicular bisectors. And the 3 perpendicular bisectors are concurrent, and they meet at a point called the circumcenter. So, we know that a point is a perpendicular bisector if it's perpendicular to the side that it's intersecting and also touching the midpoint of a side that we're intersecting. So, since the perpendicular bisector is equidistant from the 2 endpoints of the side that it's crossing, in a triangle, the circumcenter will be equidistant from the vertices. And if you don't see that, let's look at this geometry sketchpad demonstration. Now, we're going to show only the perpendicular bisectors and hide the angle bisectors. And if you see, all of those perpendicular bisectors, no matter what type of triangle I make, will meet at the point called the circumcenter. And if you notice that circle represents the distance the distance the circumcenter is from each of the vertices, because the circle hits all 3 of the vertices. So that represents the distance from the circumcenter to one of the vertices. So the circumcenter is right in the middle of all the vertices. So we can use that to our advantage when we're solving problems that have perpendicular bisectors in them. So if we look at this problem, we know that PA RA and RQ are all equal to each other because they all represent the distance from the circumcenter to the vertices. So we can use that to help us solve for x. Since we know 8x plus 16 is equal to 24, we can now solve for x by setting those two expressions equal to each other, subtracting 16 on both sides, and we get 8x is 8, and when we divide by 8, we get x is 1. So, just to recap so far, the incenter is where the angle bisectors meet. That's equidistant from the sides. The circumcenter is where the perpendicular bisectors meet, and that's equidistant from the vertices, or the angles of the triangle. The third point of concurrency is called the orthocenter, and that is the point of concurrency of the altitudes. Now, unfortunately, or maybe fortunately for you, if you don't like geometry, there's nothing interesting about the altitudes. It's not equidistant from anything, usually. The last point of concurrency that we'll learn about is called the centroid, and that's the point of concurrency of the medians. Remember that a median is a segment that connects the vertice of one triangle, or the vertex of one triangle, to the midpoint of the opposite side. So there is something special about the centroid, and it's that the centroid of a triangle divides each median into two parts, so that the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint. So the distance from L to U could be represented by 2x, and the distance from U to P could be represented by x. So in other words, you could fit two UPs inside LU, because the distance from L to U is double the distance from U to P. So you can use that to solve this problem right here. If we know that UP is represented by the expression 8y minus 5, and UL is represented by 14y, we could set 14y, which is the distance from L to U, equal to 2 times 8y minus 5, the distance from U to P. Because we know if we double the distance from U to P, that will equal the distance from L to U. So when we solve, we get 14y equals 16y minus 4. I'm going to add 4 to both sides and subtract 14y and get 4 equals 2y. When I divide both sides by 2, I get y is equal to 2. And there is another cool thing about the centroid. It's often referred to as the center of gravity. So if you have a triangle and cut it out of regular paper, maybe cardboard, find the centroid by finding the 3 medians and seeing where they intersect. If you put your finger under that point, you will be able to bounce the triangle on your finger or with a pencil. So let's look at someone doing that real quick. So this lady right here has cut out a triangle in cardboard and connected and drawn all the medians and connected them at the centroid, and now you could see that she could balance it on her finger. This lady will do it as well, and it's just a pretty cool trick that you could try at home. And it's scientists and people who design certain objects that they want to balance will often find the centroid of the figure and use that as the point of balance. So thank you for watching this video. I hope it was informative, and have a good one.